Civil Engineering Orientation Reporting by Group 7. By the way, I am Lady. Our topic for today's report is all about water resource engineering. And we have two lesson objectives. The first one is define what is water resource engineering and enumerate the importance of water resource engineering. Introduction. Water resources engineering is the study and management of equipment, facilities, and techniques that are used to manage and conserve life's most plentiful resource. In addition to assessing how and the best ways in which to control water as it pertains to water-related activities such as irrigation, waste disposal, and canal development, water resource engineers are also frequently involved in water management to ensure that it's safe to drink both for humans, plants, and animal usage.
Water resources engineering. Water resources engineers are concerned with the structures and processes related to the water supplies for human consumption and the removal of water for safety. Water resource engineers may be tasked with the awesome responsibility of ensuring that the planning and management of available water supply are adequately leveraged and remain safe to use for as long as possible. They may be also involved in water treatment so that the quality of water is improved upon the various end uses, whether that's recreationally, commercially, or industrially. Upon hearing what water resources engineers are, we will ask a question. Why is water resources engineering important? Resources, by at their very nature, are finite. There are only a small handful that are naturally renewable, such as wind, solar, hydro, and biomass. While water may be renewable in terms of the many different ways it can be used and reused, it's not as abundant as it once was, which many earth scientists and climatologists point to as a function of climate change. This figure is a representation from the Bureau of Reclamation of the world's water supplies. The Bureau of Reclamation provides some perspective as to just how limited this resource is in terms of usability, despite its vastness. If the world's water supply were roughly 26 gallons, the amount of fresh water available for safe usage would be the equivalent of 0.003 liters. That's equal to roughly a half teaspoon.
Why is water resource engineering important? Water resource engineers may be charged with developing new systems or processes for private or government entities that can preserve freshwater sources and find new ones. This may require the assistance of civil engineers involved as well, designing water purification methods to desalination or creating new equipment for contaminant transport when water is used for irrigation purposes. Understanding what works and what doesn't when it comes to water resource management is often a combined effort and may involve a number of different analyses, including hydrologic, which is the study of the water cycle and directions in which it flows, which may be influenced by weather and other environmental forces.
Functions of water resources engineering: planning and designing water distribution systems, sanitary and stormwater collection systems, and the pumping and storage infrastructure required by these systems, designing highway, drainage systems, and conveyance structures such as culverts and bridges, managing floodplains and municipal streams, and developing floodplain maps and management plans, managing rivers and reservoirs for recreation, flood control, irrigation, and other multi-use functions, developing groundwater resources, and remediating polluted groundwater resources, designing the hydraulic features of new hydraulic structures such as dams, locks, hydroelectric stations, levees, erosion control measures, and many other applications.
Water resource engineering also deals with sewer system for storms and wastewater and irrigation network.
River engineering, including ice-covered river. River engineering is a discipline of civil engineering which studies human intervention in the course, characteristics, or flow of a river with the intention of producing some defined benefit. Hydraulic structures, including dams, spillways, floodways, and reservoir. It consists the application of fluid mechanics to water flowing in an isolated environment or in an open channel. It's primarily concerned with an open channel flow, which is governed by the independent interaction between the water and the channel.
Seepage control. It measures the safety of earth dam, depends almost entirely on seepage control through dam and its foundation. Hydrology. Study of the distribution and movement of water both on and below the earth's surface, as well as the impact of human activity on water availability and conditions.
Floods, flow of mud and debris, wave analysis.